y'all doing? I'm really excited to be here because actually what happened was a couple of years ago in 2019, I submitted a talk to ConfrontJS, and at that point I was living in Nigeria, which is where I'm from. So I got accepted and they were like, oh yeah, sure, you can come on to Poland. So I sent my visa, I sent my passport for a visa application, and my passport was stuck in the embassy for 3 months. So clearly I did not speak at ConfrontJS in 2019. And in 2020, we had that whole thing. And then there was 2021, which was like version 2.0 of the whole thing. And ConfrontJS was postponed. And here we are, 3 years later, and I'm finally giving the talk. So let's have a round of applause for that. Yeah, it's actually my second time in Warsaw. I came here last year in August. It was very interesting. I got to dance in a flash mob and I saw fire dancers. And then they did that thing, like the memorial thing, where like they blare those horns and everybody like pauses for 1 minute. So I think like Warsaw is one of the more interesting places I've been to, so I'm very glad to be here again. So yeah, like I said, my name is Jemima Abu, and I'm going to be talking to you about a guide to functional programming. So I'd just like to get a feel of the room first, is if you're like a developer or you usually code, you use JavaScript or any other functional languages, let's just get a show of hands. Great, that's a good number. So like you all will get what I'm talking about, because the talk is a bit like code heavy. So I want to make sure I'm not just like showing symbols on the screen that don't make sense. So yeah, I'm Jemima Abu. I'm a self-taught front-end developer and school-taught systems engineer from Lagos, Nigeria. I currently work for a Shopify agency in London. And you can find me online anywhere at Jemima Abu. So that's Twitter, LinkedIn, yada, 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 Jemima Abu. Let's get into it. What is functional programming? So like I said, I studied systems engineering in university, and then we had this computer science course where they taught us about object-oriented programming. So they were talking about encapsulation and inheritance and polymorphism. And I was like, I'm never going to use this in real life. This is terrible. And then I became a developer, and they were like, Jemima, you need to encapsulate your functions. And I'm like, I do use this in real life. So that's why I'm giving this talk, because it's a way of writing code that is good. That is how I would put it. Basically, functional programming is building programs using pure functions, hence the name functional programming. But when we say pure functions, what do we mean? To understand that, we're going to look into the basics of functional programming. So functional programming is based on pure functions. How that works is, you know how you have math, right? And with math, 2 plus 2 is 4. Now, in other subjects like chemistry, sometimes it depends on the temperature, it depends on the altitude. With physics, there's a lot of things, but in math, the same answers will always give you the same answers everywhere, regardless of what language it's in. That is the basis of pure functions. When you put in the same input, you should get the same output every single time. 2 plus 2 will always be 4, whether you're in Poland or you're in Lithuania, which I also lived in for 2 years. Fun antidote. So yeah, that's the basis of pure functions, input in, input out. We also want immutable functions. What this means is that the values we're passing into our code should not be changed. We want to return a new value, but we don't want to change the actual value we're already using. And then higher order functions. This is the principle of using functions as arguments. So it's like nested functions. Like, you know those dolls that when you open them, it's like more dolls inside. So yeah, that's the principle of higher order functions. It's just functions with more functions inside. And then minimal side effects. So minimal side effects is basically just ensuring your code is as predictable as possible. You want to always make sure that you know if you run a function, the function should return the expected result. It's like if you pass a login function, you should expect it to log the user in, not wipe out the contents of your laptop, because that would be bad. And yeah, we also have functional languages. So functional languages are languages that are inherently functional. You write them using all these basics. You can't write them any other way. So some of the more popular functional languages are like Clojure, Haskell, Erlang, Lisp. And I've met people that write functional languages, and I would just say they're a different breed of developers, because if I had to write Scala, I wouldn't, first of all. But also, no, it's a lot more complicated than JavaScript, for example. JavaScript, I like to refer to it as a mythological creature, because JavaScript does not follow any one paradigm. It's not strongly typed, it's not particularly object-oriented, it's not inherently functional. You can use JavaScript in whichever way you want. If you want to write like classes in JavaScript, you can. If you want all your JavaScript components to just be functions, you can have it. So that is going to be the basis of this talk. We're going to be seeing how to use JavaScript specifically as a functional language. So let's get into it. Why functional programming? What are the benefits of writing your JavaScript code as functional? First of all, I just choked out of nowhere. That was great, amazing. Like, that's a talent right there. First of all, it's less prone to error. If you're writing your functional programs the way they should be written, so you're sending in the same input, you're getting the same output, you don't have any side effects, you're not mutating variables, you're less likely to have any errors because if your code works the way it should work, then nothing should go wrong because we all live in perfect worlds where our code always works the way it should work. And secondly, the code is more readable. If you have all your code broken down into single functions that do one thing, it's quite easy to tell what that one thing does. And when somebody opens your code for the first time, they're like, oh yeah, that is a validation function, that is another function that does something else that's not validation. You understand. It's also easier to test and debug. Like we said, you have your code broken down into like tiny functions. If you're writing unit tests, you already have like the exact function you need to test. Like this function checks if something is a number. You write the test for that. If it's not doing what it's supposed to do, then you're like, that's wrong. It's so easy, guys. Like, yeah. And then also you have a lot of reusability of functions and variables. It's very easy to, because you have the one function that just does the one thing and it doesn't really change anything else, you can always use it anywhere else in your code. So yeah. And also, this is my favorite part, there's no more this. Let me tell you a fun story. So when I first started writing React, yeah, that was my first introduction, because back then, how you wrote React was with class components. You know, you had all the whole React extends this dot component, and you had to do the class with the super and the prototypes. I was writing this function, and then I couldn't get it to work. I was calling like this dot do something in one of the class definitions, and I did not understand why it was working. I did not, because it was like, oh, this dot do something is not defined, and I'm like, what do you mean it's not defined? I defined it right there. So I go to the senior developer on the team, and I'm like, this isn't working. And it's like, yeah, this isn't working because you can't use this in the function. You have to use that. Like, what the heck is that? They're like, if you have like your this function, right? It only works globally. So if you're inside another function in a prototype and you call this in that other function, it doesn't work. And I was like, is this the right career for me? Is this really what I want to be doing with the rest of my life? But yeah, basically, well, your this functions, you can't call this in another function. If you want to have it related, you have to refer to it as var self equals to this. And it makes no sense to me. So in functional programming, we don't do that anymore. And I love it. Also, arrow functions for the win. With arrow functions, you don't even have to use this. You can just like use the function name and it will do what it's meant to do. It's great. I love arrow functions. Arrow functions are amazing. So yeah, how do we actually write functional programming in JavaScript? So like I said before, React was made to be like a class component, right? Because you had to define like your this.state and you had to set your super in your class initialization. And then React hooks came along, and with React hooks, you don't need to do any of this. You can just like export default components. React hooks are based on the principle of functional programming. So we can see from, wait, I think I should have a pointer. Yes, love it. Like I'm a cat, I love it. Yeah, so with your class components, you use this a lot. So you have this.state, this.setState. When you're referring to something, you have this.state.name. But with functional programming, there's no reason for this because the code understands that you don't need to say this. Everything is in the same function, so you can just access it from anywhere. So instead of saying this.state, you just say states. Instead of using this.setState, you just set the set state value you have created already. And instead of saying this.state.name, you just use the name function. It's amazing. I love it. So yes, this is the principle of how we use functional programming in React as opposed to class components. And then when it comes to web applications, when you build your code using functional programming, it's basically just stacking multiple functions on top of each other to create your application. So this is pretty much what it looks like. It's like you have two raccoons hiding inside, and it's like, don't look in this code. We are a fully functioning web application, because it's just a bunch of functions on top of each other. So there's really nothing to explain. It's raccoons in a tracksuit. Like, you get the point. So this is the basic structure of every functional component. You have your application, and each of your application uses the function. So in component A, you would have multiple functions. In component B, you would have multiple functions as well. That was a very short section. I felt like I had more to say there. But yeah, pure functions. Let's get into it. How do we know when a function is pure? So let's take a look at this simple JavaScript code. We're calling an add function. So now we have a variable a that's equal to 5. With our add function, we're adding b to our variable a. So if I call add 6, it's going to return 11, because 5 plus 6 is 11. I'm very good at math. But the reason this is impure is because, number one, it depends on a global variable. What that means is that this function, this variable a, is not defined inside of our function. So we cannot always be sure of what our function is going to return. For example, if I change a at any point in my code, I get a different answer for the same function. So if you look here, you're passing in the same inputs. It's add 6, but here it's giving you 11, and here it's giving you 13. So now, if you think of a use case where, let's say, I want to validate a user data, right? So I'm expecting them to pass in a password, and then I will validate that password. But then somewhere else in the code, let's say I was trying to send the password to the system, and I wanted to trim it for some reason. So now I call password.trim somewhere else, and that mutates the entire password in the function, because it's kind of a global variable. So now in my code, when I'm trying to validate that password, what it's returning is the trimmed password. And if the white space character was part of that password, it kind of gives you an error that you were not expecting, because it's mutated that variable and it's changing the output you're getting, even though it's meant to not change it. That makes sense, yes. All right, so this is what a pure function would look like. A pure function is not dependent on global variables. It only works on the functions, on the variables that are defined inside that function. So with this function, no matter how many times you call it, as long as you're passing the same inputs, it should always give you the same output, because you're not relying on mutated data from anywhere else. So this is how we work with pure functions. Pure functions work on inputs only. They do not rely on global variables, and they always return the same output as long as the same input is passed in. So yeah, return same value for same input. So this is a fun little question. Would we say this is a pure function? So now we have one function, and we're taking in one input, and it's going to return an output. So is this a pure function? Yeah. Yes, it's not a pure function. Okay, let's do a show of hands, actually. If you think it's a pure function, raise up your hand. Okay. If it's not a pure function, raise up your hand. All right, that was a fair split. This is not a pure function. It was a trick question, and I got you. The reason this is not a pure function is because this would return a different output, even though the same input is passed in. So now what we would call this is, we would call this a necessary impure function, because this is what we want it to do. We want it to always return a different output. Because let's say you're trying to create like a random password for, I've been working on authentication a lot, so that's why I keep using like logging and passwords, because that's what's in my brain, but you get the point. Let's say you're trying to create a random password for a user. So every single time you would create a random password. That is the intended behavior of that function. But it's not pure because it doesn't always return the same output, even if the same input is passed into it. So that's a fun little thing to ponder on. So let's take a look at another function. Would we say this function is pure? It's also a function. It also takes in one input and it returns an output based on that input. Do we think it's a pure function? I see we're a lot hesitant to answer now. Do we think it's an impure function? Yeah. It is a pure function because it would always return the same outputs. 10 will always be the greatest number in this array. It would always return the same output for the same input. So I hope that kind of made it clear how we can have pure functions and impure functions. It's not particularly like one is worse. It's just that one is more predictable than the other. There are still use cases for impure functions in our code. And then we have immutable values. So these are values that shouldn't be changed. So let's take a look at this nice little code right here, which I wrote all by myself. Basically, we're trying to reverse an array. So what we have here is that we have a global array function, and now we have array.reverse. So this function is going to return the reversed version of this array. But let's take a look at what happens when we actually call this function. With JavaScript, if you run the .reverse function on an array, it mutates the original array. So what happens now is that we're calling new array, and it's like giving us the reverse thing. But the array itself is also mutated. Like I said, JavaScript is not a strongly typed language, so it does not follow the same rules that a lot of other languages would follow. So that's why you have to be a lot more careful in your approach, because now we have our global variable mutated. If we're trying to use it anywhere else, that'll be a problem, because obviously it's not giving us the same answer anymore. So that's why in JavaScript we use things like spread operators. what this does is create a new instance of the global variable we're working on. So now, technically, this function itself isn't pure. But the way we're approaching it is that we're making sure that despite the fact that we're using a global variable, it's still a new instance of a global variable. So it's technically pure because technically it's a new instance, you know. But yeah, basically spread operators, they always create a new instance of an array. What that means is that this function should not have any effect on the global variable that has been defined outside. And yeah, it will return our reversed array, but it will still leave our variable in the original way, which is what we want. Yeah, array is not mutated. Excellent. And then we get to higher order functions, which are basically just nested functions. So taking a look at working with arrays again, or an object or whatever, let's say we have a function and we want to double every element in the array. So we call a for loop and we're like, for whatever, just set the element in the array as ×2 of what that element is and then return the array. This would also mutate the original value because what we're doing is that we're replacing every instance of that thing that we just passed into. So even though it's an input that we passed into a function and we're not directly calling like this value itself, it still mutates it because JavaScript. So that's why we have to use higher order functions. Higher order functions in JavaScript, changes array value, yeah, we got that. Higher order functions in JavaScript are functions that are used on like your objects. So here we would use map is a higher order function because it's a function that takes a function as a parameter. So what we're doing with map is that we're passing in the parameter, and the parameter is whatever item is in our array. And so we're passing that in. So when we call this function, we no longer mutate our values. So basically, it's the principle of functional programming, right? It works in steps. So we start with the basis of pure functions, and we realize that if we can't use pure functions, we have to move on to at least making sure that we're not mutating any values. And then we move on to using higher order functions to avoid mutating values. So it's like a nice little trilogy of events. Yep. And then finally, minimizing side effects. So like we saw earlier, there are times that it's necessary to have impure functions. In a similar fashion, there are times it's necessary to have side effects. But first of all, let's take a look at some unnecessary side effects that we can have. With this function, this is a pure function. It's taking in a value and it's returning an output based on those values. But it's also doing something else other than returning a value. Here, we're console.logging something. Like we did this a lot in our code because we're trying to like test stuff. You know, you want to make sure like a value you're getting in is what you're expecting. But there's a reason you wouldn't push console.log to production because, I mean, sometimes you do, and then somebody is like, why did you push console.log to production? And you're like, did you not see it in the peer review? It's not my fault. But the point is, you should not be pushing console.log to production or putting it in your pure functions. Pure functions should only return the value. They should only return an output for whatever input you pass into them. That is the basis of a pure function. Another side effect to the pure function is if it's doing something like mutating a global variable. So now we can see with this function, we're not passing in any value. We're just directly referencing the global variable. So this is kind of like the backward step from what we do with higher order functions, because at no point are we creating a new instance or using a higher order function on our variable. We're just calling it directly. This is also a side effect. Anything that requires you to directly reference a global variable is a side effect. So don't do it. And then that's pretty much it for the basics of functional programming. And now we'll go into the applications of functional programming in JavaScript. So like we said, we have React functional components. React functional components are functional by default. It's a function that returns a value, and it takes in parameters. If we have like, you know how you have like a button component, so the button component could take in props like color or is active, and it would return a button. So that's like, that is a pure function because it's taking a parameter and it's returning. You would always expect it to return a button. If it doesn't return a button, something is wrong with your button component, so you'll go fix it. Another example of functional programming in JavaScript is Redux Reducers. The basis of Redux Reducers is to be functional because you're passing the state and the action, and you only return one value based on whatever input was passed in. So if I pass in state and the action is authorize, I will carry out whatever is in this case authorize and then return that. And the default function is returning state. So Redux Reducers in themselves are functional because they always try to avoid side effects. I'm sure I had something to say on this, but moving on. Handling necessary side effects. So like we said, there are sometimes that it's necessary to have side effects because let's be rational, we are writing complex programs. We don't live in perfect worlds where we're only returning functions that reverse arrays and add two variables together. Because that'd be a very easy job. If anybody is willing to pay me to do that, let me know. I will be here afterwards. So let's talk about some necessary side effects we can have in our programs. Asynchronous effects, not effects, requests. Asynchronous requests. When you make a call to an API, you're passing a value. So remember how we said like we don't want to have side effects? Like if we're passing an input to a function, we want to always return a value. In JavaScript, sometimes you're passing an input, so a user fills out a form, they're passing the input of their email and their password. What you're meant to return to them is either like a login confirmation page or an error page. But how do we actually know what they're passing in is necessary? That's how we have our side effect. The side effect is making a call to an API to validate their request. Because you can see like now, that function we've created is doing two things. It's making a call to an API, it's getting the request back, and then it's letting the user, it's returning a value to the user. So that is what we would call a necessary side effect, an asynchronous request. Also logging. We don't want console.log, but we have to, because you need to test things sometimes. Console.logging is a necessary side effect. Things like rerouting functions. In React, when you're trying to reroute a component, routing itself inside a function is a necessary side effect. And then things like just periodic updates. Sometimes you set timer or you set interval, and whatever function is happening within that, your set timer or set interval is a side effect. So this is an example of what a side effect would look like in like a use case. We would have our API fetch, and it would return something. So now we have this function, our logging function. On the surface, it's just taking in a parameter. This is meant to have a parameter details, and it's returning API fetch. But when we get to API fetch, see that API fetch is also carrying out another method and returning more stuff as well. So it's kind of a side effect, but it's like a necessary side effect. So yes. And that brings us to the concept of middleware functions. So like we said previously, Redux is a functional component. It's built for writing functionally, and it's not built to handle side effects. But what do we need to do when we actually require a side effect in our Redux code? What do we need to do when, before we authorize a user, we want to, you know how sometimes like the user clicks the button and then you want to disable the button while you're getting the request? Disabling that button is a necessary side effect, but Redux was not built to handle adding a class name to a component when you're making an asynchronous request. That's where the concept of middleware comes in. Middleware is, ignore that. Middleware is a function that we put in between two functions to carry out magic on those functions and then pass it somewhere else. So with Redux, you have your action. Your action is authorize. And now we dispatch that to Redux. But before we authorize, we want to disable the button. So the disabling the button and everything is handled in the middleware. And after all of that is carried out, then we pass on the modified action to the reducer. I hope this icon, this little diagram was very clear to explain it because the code is much more complicated. 5 minutes? Great. All right. So with Redux code, what we have is, first we have a store function, and then we have a next function, then we have an action function, and then we return what was in the next function. Now, when I saw this, when they were like, oh yeah, we have to write middleware for this, I was like, what the heck is this? It was very complicated for me. But yeah, basically what's happening here is, first of all, the store function is the default function. That is when we are passing, and we're calling the store, basically. The store function is what calls the store. And then we have our next function. So the next function is what actually passes that action to Redux. And then we have our action function. The action function is where the middleware logic takes place. So if you want to define anything to carry out a side effect, you would put that in your action function. So this is where I'll put my disable button and everything. And then finally, I would return the actual dispatch action that Redux is meant to carry out. Am I low on time? Ah, I'm done. Beat the time, yes. In case you want access to my slides, you can just go to jemimaabu.com/talk/functional-programming, and you have access to it. I also have some resources for further reading if you are interested in functional programming and you want to read up some more. These are some really cool articles, and you can check them out. And thank you very much. Do I have time for questions?